right, there we go. So we should be recording now. Everyone can go back and look at this later if there are questions. Okay, cool. So the point of today is a very low-key tutorial on QGIS. If you're not familiar with it, this is a geographic information system or geospatial information system. And I guess the main point that I will make up front is that this is not a data source in and of itself, right? So you have to go and find the data, and then you can use this to bring all of the data together in one place, like look at it all, in the same image, basically, or like overlay different data sources to look at them. But yeah, if you go and download this, there won't be like a magic button to get Landsat or Arctic DEM or something. You'll have to go to the separate data download sources for that kind of thing. But what this does let you do is take data from a whole bunch of disparate sources, as long as they're sort of geo-referenced in some ways. You've got like X and Y or lat-long coordinates associated with this thing. And it's on the surface of the Earth. This doesn't really do 3D data very well. It's mostly like flat on the surface of the Earth stuff. And you can pull it all in here and not only visualize it in a variety of ways, but also do a degree of data processing on it. So if there's well, it can do some moderately complicated things. I would, for the most part, say all of you guys are smart enough to do that more effectively in MATLAB or your chosen programming language of choice. But it is very convenient for some of those things if you're like, oh, I want to change what coordinate projection system I'm in, which in theory I could do the mathematics and trigonometry for, but also I could just click this one button in QGIS. So it's sort of useful for a lot of those kind of underlying more like data prep types of things, as well as kind of the visualization on the back end. So at least like when I use this in a workflow, it's usually sort of at the beginning of my work when things are kind of exploratory. I just want to kind of look at a bunch of data sets and see what's going on. After the hardcore analysis will then happen like somewhere where I can, actually program and like work analytically with the data. And then it often comes back into QGIS at the very end, so I can make pretty maps or figures to go into the paper. So very useful, I would say, on the sort of exploration and then visualization ends of a workflow. Yeah, so I think for today, what I'm going to do is just walk through sort of a basic use case that you might have, or that I often have, of like, let's explore some data in a place in Greenland, and then try to like dive into. Okay, we're good now.
Sorry, guys, I forgot. Yeah.
All right. Yeah, so we'll just sort of step through like adding some data sets, a little bit like how that works in the system, and then maybe ways that you could like use this to sort of explore some stuff. So our use case today will be, what if you wanted to decided you want to look at Jakobshavn Glacier in Greenland and see if there were like interesting lake features in Jakobshavn and how they're changing with time. Most of the stuff that I will show you today, you could use for many other use cases, maybe even with the same stuff. So if we're going to do this, maybe the first thing we want to do is just some like context for Greenland. So we could, for example, load in like an elevation map of Greenland. We have a pretty easy one that comes from Arctic DEM. And so this is probably like when you open QGIS, like the most basic first thing that you would want to do, presented with a blank project like this, is like put some data into the project. And in order to do that, you really have to do like no other setup. There are things you could do, but you don't have to. You can just open the program, like click new project, and then start adding data. So in terms of adding data, most of that happens under this layer button up top. So this is what they like to call your different data sets, your layers, because you can stack them on top of one another. So if you click on layers, then you'll have an add layer option. And then this lists all of the different types of data sources that you could pull in, which is a little bit overwhelming. But the two sort of, okay, so there's three ones that you would probably use the most. And so that's going to be these top two, vector layer and raster layer, and then probably also the delimited text layer option. So we'll talk a little bit about each of those as we go through with it. What we're going to start with is a raster layer. So a raster just means something that has pixels. So this is like an image or a digital elevation map, something where your data is gridded up and you have like a value per grid cell. And so that's like a lot of what we end up working with, I think, which is pretty straightforward. So if we want to pull an elevation map, that's a raster. So we can click on add raster layer. And then you just go into your file system, wherever you're looking. You guys are going to get to see the horrifying state of my data drive in real time today. DM. So we'll add the Arctic DM 100-meter. Then you just click add. And there you go. Now you have your elevation data in there. So you'll notice that once we added that, it shows up here in the middle screen. So that's your map view. You can see all the data sets you added. And then it also shows up on this little layer list here on the left. And so as we start to add more things, you'll just get a long list of everything that's like in your map file under here. Now, if you right click on this guy and go to properties, this will tell you a bunch about the data set you've actually added, assuming that your data provider adds metadata to their files, which is maybe not a given, but if they did, you will be able to see it here. So in general, you always just see like, what's the file name? This is often very useful. Where in your own file system is that file, should you need to go find it for something else, because I always forget when I add them. What its size is, last modified. And then, so information from the provider, this is stuff they would have had to fill out, so it may not be associated with every data source that you pull in. But this one, they were sort of moderately good. So it'll tell you the spatial extent, like what XYZ or what long area it occupies, what kind of file it is, what your data type is. So this one's a 32-bit floating point. You might have other ones that are like an unsigned 8-bit integer or something like that. I would say that often doesn't matter as much in QGIS, but if you're going to pull this data source out to do some like actual computing on or like analysis in Python or MATLAB or something, you would probably want to know what this is, because that's going to change sort of what other data types you use it with and sort of how you interact with it in the programming environment. It'll tell you what your dimensions are in terms of pixels. This one is a little useful. So this thing called bands here, we have one band in this file. So this could be multiple numbers, and you'll often find that's the case if you have like color imagery, for example, right? Because like a natural view image is actually in the same way that our eyes do kind of like red, blue, and green cones. You have red, blue, and green like options in your camera that are like filtering for each of those wavelengths. And so when you get like a natural color image that actually consists of 3 images, one for each of those spectral bands that are being combined together in some way. And so if you loaded up a natural color like Landsat image or something in here, you might see that it would have 3 bands, one for red, blue, and green. And so you could manipulate those individually or sort of as this combined whole, depending. And then it'll tell you about the coordinate reference system. So this one is really useful because this is telling you how your spherical kind of bumpy Earth is being projected onto a perfectly flat sheet of paper. And also where like X, Y, and Y equals 0 is on your map. And QGIS is really good about this, and they do what's called reprojection on the fly. So that means you could throw in like 6 data sources, each with like different datums, different projections, like different coordinate reference systems, and it'll just figure it out and like overlay them properly on the map together as long as that's been defined. But if you try to go and run some of the analysis tools and they're not in the same reference system, then it will often throw unintelligible errors at you, or just freak out in some way. And so if you're trying to like run a geoprocessing tool, if it's not working, like one thing to check is like, are all the data sources that you're using in the same projection, same coordinate reference system, and is it an appropriate run? So there's usually like 2, I would say in glaciology data sets, you're really only going to see 2 most of the time. So one is going to be geographic coordinates, so this is like latitude and longitude. Usually that'll be in the WGS 84 datum, that's kind of the standard. And so the other one that you'll see would be a projected coordinate system, which is usually what we have here. So this NSIDC, sea ice polar stereographic north if you're doing Greenland, or stereographic south if you're doing Antarctica. And so the main difference here, right, is that a projected coordinate system like this one has taken around Earth and flattened it out in some manner around some reference point onto a flat sheet. And so now we have measurements and points in like meters from some reference point. And so if you want to do some kind of like measurement on your map of like, what is the perimeter of this like shape that I just outlined, or what is the distance between these 2 points, you probably want to be in a projected coordinate system and not in latitude and longitude, measured in degrees. And so some of the processing tools know this and will just spit errors like, we can't calculate this at you if you're trying to measure a distance in a geographic coordinate system. So in general, I would say like just always put everything into the stereographic north if you're working in Greenland, or the equivalent projection if you're working in Antarctica before you start doing stuff in here, because then everything just plays nicely together. And typically if you're pulling stuff from like any of the glaciological like data sets, it'll either just be in that long or it'll be in one of these projections. So there are many, many thousands of these projections. The way that you can check that you're like always using the right one is this EPSG code from the European Petroleum Society of something or other that does not exist anymore, but still need these codes up. And so it's just a unique like identification number that goes for every projection. So for Greenland, you always want to be in 3413. It's 3031 for Antarctica. And if you're just in lat long, this will be in 4326. You can Google these. There's like a whole website that's devoted to just telling you the projection names and numbers. But a useful thing to like check that you're doing. Yeah, cool. So we have some data. We know a little bit about the data. Yeah, of course. Yeah. Yeah, so QGIS is pretty good at opening a lot of different data formats, but I would say that so the one that is by far the easiest to use with like any GIS system that I think is fairly universal is GeoTIFF. And so MATLAB and Python can definitely like export things directly to GeoTIFFs if you have like coordinate positions for everything in your grid and it's on sort of a normal grid. So that's one way to do it. You can also do netcdf files with a map projection and provide that. That's a little bit trickier. It just you have to know like how to write the netcdf file to provide like the little tagline that basically tells it what the projection is in a system like this, which is not like terribly hard to do, but it's a little bit. It's so like MATLAB, if you like export to a GHF, kind of takes care of that for you. For netcdf, you'd have to like write that in yourself. But yeah, exactly. So if you export to a GHF, it has both all of your data in the grid, and then it also has some basically like text metadata that says, okay, your coordinate reference system like starts from this point, in your upper left-hand corner is this, grid, and this your lower right is this one, and so here's your pixel size, line everything up according to that. Yeah, so very convenient file format and pretty readable by most things. Yeah, just like yeah. Yeah. Mhm.
Very specific. So, but that means actually I don't have the specific coordinates.
Yeah, so if you were doing this in MATLAB, you can extract that information. So if you do like the read georaster function in MATLAB, there should be two outputs to that function. One is the image file and one is like your projection information. So if you take the projection information, you look at that, it will give you all of the information that you would need to calculate what the x and y coordinate of every point in the grid is. You have to do a little bit of math because it's basically they tell you like what the upper left-hand corner is and what the pixel size is. So you've got to take the upper left-hand corner and like add your pixels to make it like an XY grid. If you want to, I have like a function that I wrote at some point that just does that. So I'm happy to share that with anyone who thinks they might want to read GeoTIFFs in MATLAB. Yeah, and just having like it. All right, so that was metadata. That's super fun and everybody's favorite thing. So maybe we'll just make a pretty picture now to show you kind of what the geoprocessing type of stuff can do. So when you open QGIS, you'll have this bar on the right-hand side. It's called the processing toolbox. If for some reason you don't see it, you can come up to processing and click on toolbox, and then it'll show up. And so these are basically all pre-written functions, like pieces of code, essentially, that you can run on the data that you have pulled in as a layer. So what's great about that is somebody already wrote and validated code to do all of these things. What's not great about that is sometimes the documentation is crap. And if you care deeply about exactly how it calculated that thing, you might be better off running it yourself. But very useful for some of the like baseline processing stuff. So the one I'm going to run right now is called Hillshade. This is, if you're working with like DEMs and stuff, this one's really useful, right? Because if we look at like this picture of Greenland in elevation, it's a little hard to interpret. You don't actually see a lot of features. And so the idea of running Hillshade is that this is going to give us something that kind of looks like what the ice sheet would actually look like. We're basically going to like illuminate it with a fake sun from a certain angle and like make a picture based on that. So basically this will cause all of the features to like really pop out on the surface, like even if it's very small elevation differences. And so if you want to run Hillshade, you can set the angle of illumination for the sun. The one that really matters is the Z factor though. So this is how much we're going to vertically exaggerate the elevation. Usually you want to do like a factor of 10 at least to get it to flat surfaces. Yeah, and so you'll see when you're running like stuff in QGIS, you'll always have this option here at the end to either save to a temporary file or to save to somewhere on your hard drive. So save to temporary file is basically just going to put this into like a cache that gets erased when you close the program at the end. So if you have like intermediate step products, like you're going to run like 3 or 4 processing things in a row, maybe you don't need to save all of those intermediate products and take a bunch of the space. You can just do this temporary file thing. But if you want it to be there the next time you open your project, then you need to save it as a real file somewhere on your hard drive. Just click on that, save the file, put it somewhere. I'm going to do it as a temporary file. I don't use it after this. And then you just hit run, and you sit there for a little while it chunks along. It is definitely RAM hungry. I would say that for the current iteration, if you don't have 8 GB of RAM, you will have incredible regrets trying to run this program. So you definitely want at least that on your laptop. You can't really have too much RAM. It will always be happy with more. And you do, I would say, want a fair bit of disk space. So in general, you're going to need a couple of gigabytes just and then if you're doing this temporary file thing, like every temporary file you generate is just like getting saved temporarily to your hard drive somewhere. So if you generate like 17 temporary files from a file that was like 3 gigabytes, like you now have all of that sitting on your hard drive until you close the program. So yeah, you probably don't want to boot this guy up if you got like 1 gigabyte of spare space on your hard drive. That's not going to go great. Yeah. Yeah, LabComputer is a good place for it. I mean, I run this on my laptop, and it's pretty much fine. It can get slow occasionally if you have like a bunch of layers. And you'll probably see in this tutorial when I'm like zooming in and out on like high resolution files a bunch, it'll just like for a second. But yeah, if you put it on something like the lab computer that's has a little beefier specs, then it should run pretty nicely.
That's how I do it. I have
Cool. Yep.
The data is actually from somewhere on the cluster. So then without data transmission plus wait you zoom in. You know, it could be
Yeah. Yeah. Yeah, that's been my experience. QGIS is fairly smart about caching, especially at different zoom levels. But yeah, if you have it like sitting somewhere that has a little more latency to access the data, then it will definitely take a bit more time, or you'll get more lag when you're zooming out on things, which can be a little bit annoying. But if you have really big data sets, it may be inevitable. You just have to live with that. Yeah. All right. So we got our hillshade, and you can slowly zoom in on this and see why this is cool, because now you can actually see a whole bunch of like features on the surface of the ice sheet from your elevation map. So I would say in terms of like data exploration tools, this is like my most favorite, fun and easy one, which is like throw your elevation map in, run a hillshade. Now you can actually just look at it and like, oh, well, there's probably some like streaming ice here. And up here, we've got a bunch of lakes and all of these like weird flat spots, and there's like bumpy topography and stuff like that. So yeah, and so this is just like the mosaic 100-meter posting DEM from Arctic DEM. So it's pretty good like upfront exploration tool for anything that's maybe over 500 meters in size. Kind of scroll around this thing and like look for cool places. see what's going on. So yeah. Yeah, so this one that I'm showing right now is the mosaics. This is a combo from different times. You could get the individual strip DEMs and also do a hillshade on them. And actually, usually when you download those, they come with a pre-created hillshade file. You can draw in and look at them in the same way. But yeah, this is just, mosaic of many times into one image. But it can be useful for like a first scroll through to see what's going on. Yes, this is the hillshade. So the next thing that we might want to do is actually like go to a specific place in Greenland. This is my pet peeve in papers that you may have discovered. They're like, we studied X glacier with a funny name. You're like, I would really love to know the coordinates of X glacier with a funny name. So this is where QGIS can also be useful. So what we're going to do is we're going to add a vector layer now that has little labels for each of the glaciers in Greenland. So we do the same add layer thing, but now we go to vector layer. So all that vector layers are is basically a layer that contains points, lines, or polygons. So if you just wanted to like put a dot somewhere and be like, this coordinate, is like has this name or something like that, or maybe you wanted to draw a road, so you just want a line down the center line of the road, or like, color in like a perimeter of a lake, something like that. That's what you use a vector file for. It's much more efficient for storing that kind of stuff than it would be with a raster file, like an image or something like that. And so those are pretty popular. The other thing that's cool about them is that they basically come with a mini database. So the file is for each point, for example, is not just giving you like the coordinates of that point, but you can attach attributes to it and say like, okay, I have a point at this XY coordinate, and maybe the name of the point is this. And, say they were like places where you like left your instrumentation out on the ice sheet. You could have a field that says like, oh, this is like the name of the particular instrument. This was its model. This was like the date that we set it out there, or something like that. So you can have like extra information added to those points. So these come in a variety of files. One of the more popular ones that you'll probably see is shape files from mastering. So that's these .shp. Actually, a shape file is a series of 6 files all combined. So if you use these or make them, don't panic when you suddenly saved like 7 files when you thought you were saving 1. So like in this case, everything here from the dbf file down to the shx file is actually part of this single shape file and its database components. But to open them, you just, in this case, like click on the shp file in QGIS. We'll figure out all of its other ancillary files and like use them with you together. But these ones that you may have seen, like with Google Earth, the KML or KMZ, that's another example of a vector data file. Those are getting pretty popular these days. You may see GeoJSON or WKT, well-known text files. That's another way to do all of these things. Just QGIS can pretty much read any of those. It just depends on sort of where you're getting the data from, what people thought was most useful to have. We'll open the shape file. All right, cool. So we got a whole bunch of points for all the glaciers on Greenland. So if you have a vector file and you go here, you right click on it, you can do this thing called open attribute table. So this shows you the little database associated with every point, right? So now each of them has some kind of unique ID, latitude and longitude. In this case, we have the current Greenlandic name, the old Greenlandic name, the foreign name of the glacier, and now its official name. So it's from a paper. Yeah. So, well, there's many names because there is what is called in Greenlandic written in the, I guess, old orthography, and then they sort of updated how they translated Greenlandic sounds into Latin script. And so now you have the new Greenlandic version of the name, which is just a different spelling, but the same pronunciation. And then the foreign name is like whatever the Danes or some random Norwegian who thought they were the first to wander into that glacier named it. And then the official one these days is usually just the new Greenlandic name, unless it was not named in Greenlandic. So this file in and of itself is extremely useful because the literature may use any possible combination of those names in Greenland. So trying to figure out which glacier they're talking about. You may want this file just for that. But yeah. Mm-hmm.
Somewhere useful for just putting on.
Yeah. Yeah. Definitely anything I show today, I can just zip up and drop in projects. And then, yeah, there's other stuff people. Yeah, you can do that. Cool. Yeah. All right, so one of the cool things, because we have this database, is you can now basically like search on that database to find things spatially. So in this case, let's say we want to just like look at Jakobshavn for our exploration today. We can do this thing called select by attribute. And so this is going to allow us to basically just ask that shapefile, like select for me the one point that has Jakobshavn in the name. So yeah, we're going to look at Greenland glacier names. We want to look at the foreign name. We want it to contain the word Jakobshavn, and we're going to create a new selection so we can run that. And see, we've got that little yellow point now, so it found the glacier point for us. And if you, again, right click and hit zoom to selection. So I think this is a nice way for navigating around if you didn't get coordinates from the paper or something else. You can do it this way. If you do have coordinates, this is where the delimited text file is really useful. So if you go to layers, add layers, and you have this delimited text layer option, this just lets you import literal text files in. And so if you take like a set of coordinates in latitude or longitude or in XY, just write them comma separated into a text file, then you can load that up here and it'll put little dots on the map for where those are located. So when they do give you a list of locations with coordinates, that's the easiest way to do that. I guess unlike maybe some online viewers you've seen, there isn't like a magical little search bar where you can just type in coordinates and have it zoom in. So the workaround for that is you type your coordinates, any that you're interested in, into a text file, upload them that way. One of the slightly more unfortunate things. But yeah, okay. So that's Jakobshavn. And maybe one other thing that we would want to do for context is like add some velocity maps. So I'm going to do that. So this is adding more rasters. That's just sort of the standard thing for a lot of the data sets that you'll add. Do the ESA data. So here I'm adding some data that comes from the Sentinel-1 synthetic aperture radar for velocities. It's processed by the European Space Agency, hence ESA in the name. This was a mosaic from 2016, 2017. So we can add those, and you will see that, you know, it kind of looks like crap and you don't see much right now. So one of the things that QGIS is extremely good at, probably much more conveniently good at than trying to do this in like MATLAB or something, is changing up the visualization. So if you go into properties and then into symbology, you have this whole set of options for how you want the layer to look. So the one that you'll probably use the most often is this single band pseudo color. So this means I only have one band in my data file, and I want to make it some pretty color ramp and not anything related, you know, to the not something defined by the you know, file or anything else like that. So you go to single band pseudo color. So you can set like the minimum and max values that you want to show here. This is in meters per day, by the way. That's why these are so small. You can set the various color ramps, to which you can also add your own if you find other ones that you like better than what they have built in here. You can choose how you want to classify it all, do some blending modes, some other stuff. So click OK on that. There's our velocity map, looks a little bit more normal. And you can also copy styles pretty easily, which is great. So if you go styles, copy style, and then you can paste that style onto another layer. So now we've got our X and Y looking the same, which is pretty convenient. So so we can work with the velocity maps, and we wouldn't necessarily be able to create velocity from other things with this program. So yeah. Oh yeah, so that's exactly what I'm going to show now, is that you can definitely do basic math with this. So we go up here to raster. This is stuff that you can do to your rasters. The first one is called raster calculator. And so this lets you basically do any like relatively simple mathematical function that you can define like on a set of the rasters that you've included here. So, you know, in this case, we could get the magnitude of the velocity by just adding these two components in that. And again, you have this button up here. If you don't want to save this to your file system somewhere, you can create the on-the-fly raster or the temporary file. It doesn't get saved forever. Yeah, okay. Do that. You can also reorder things just by dragging them around here. go in there and switch this up. So you probably don't want a diverging color bar because everything between should be 0 for now. So there we go. So one of the other things that's really nice for visualization is you can get it to just like blank out certain values if you don't want to see them. So like right now we have this problem where the inside of the ice sheet and the ocean look the same because they're both just very low values. But if you use the little identify tool, so this guy up here, you can get like values by clicking on things. So we can click on the ocean, click on the layer that we're looking at, and we see, okay, actually the ocean is this like negative 3.4 times 1038. So probably we don't want to show those values because that's just what they're using for like no data. So you can copy that value. And then if we go back into our properties, there's this transparency option. And you can basically say in here, okay, I want values from, in this case, negative 3.4 times 10 to the negative 38th to say like -1 to just not show up. You apply that. All right, so now we have velocities that are just on Greenland, which is a lot nicer. This is a very nice feature when you're trying to make pretty maps. So there you go. You watched it kind of bug out and you zoomed out. It's getting a little bit slow. Oh, so those are areas where you can see Arctic DEM from underneath. So it's probably places along like the edge of the coastline where Arctic DEM goes out into the ocean for some reason, and the velocity map doesn't. If this manages to zoom in here, you'll be able to see that. Yeah, so like you can see you got velocities on the little bits of land, and then the Arctic DEM strips went out into the ocean, and the velocity doesn't. So you're seeing the layer underneath because there's nothing overlying it. Yeah. And I guess one of the other cool things that you can do with the symbology is you can do layers as overlays. So if we do that, then we'll turn off these guys. You can basically have your velocity like overlaid and see your hill shade underneath. So this is a favorite for posters. Gets you lots of bonus points when you use that. See if that yeah. Yeah, so that's a very basic example of using the raster calculator. You can do more complex functions in there. I've not figured out an easy way to do differentiation in QGIS, so you can't quite get your strain rates. But if you had strain rates, you could actually, in theory, do the whole like stress to strain calculation like in QGIS directly. Again, this is a place where like you can code that more easily and test it more robustly in MATLAB or Python. But like in principle, if you really just didn't want to for some reason, like it can do that in a program like this. Cool. So I'm just gonna also add another or where the ablation zone starts. So that's an interesting thing for things we might be looking at. And so you can also do a whole bunch of symbology stuff with vectors. So like I just added this line for the ablation zone, and maybe we want that to be much more obvious. So you can go in here, you can change the colors of your lines, you can change how fat they are, you can make them dashed, whatever else shows up. Pretty convenient. Yeah, so maybe an interesting thing that we would want to do now is like zoom in and find some like lake, maybe near the equilibrium line, and like see how it's changing over time. So we'll do that. I'm just going to zoom in on this guy because it's a big looking lake and looks kind of fun. So if we are interested in this lake, then one of the other things we can do in QGIS is not just add a bunch of other people's data sets, but also create our own. So what you might want to do, for example, is like add an outline of this particular lake you're interested in. One, so you can like keep finding it on the ice sheet every time. And two, because if you want to pull in other data sources, oftentimes if you like go out to their website, they're like, oh, give me like a shapefile or a KML of your area of interest, and I'll give you all like the ISAT lines that overlap that, or the images that overlap that. And so you can use QGIS to like make a little file that isn't just like a boring square bounding box, but is actually like the shape of the particular feature that you're interested in, or maybe that feature plus some buffer, and then export that out so you can use it to search for other data sources. So creating files is like super easy. You'll go to layers. This time you're going to create a layer instead of adding a layer. I usually just do shape files for everything. So you get a prompt. It's like this. If you're going to create a layer, you have to actually save it somewhere. Save it in QGIS tutorial. We'll call this cool lake number 2. that'll create everything. Yeah, it's when I was like running through this morning to make sure it would all work. So with vector files, you're going to have to pick what the geometry is. So it can either be a point or a line or the polygon. You don't get to have both in the same file. So for this, we want to outline the lake, so we don't want to be a polygon. It's going to be a full 2D shape. You get to pick what coordinate system it's in. Right. So right now, this would, if we did it without changing anything, this would be just in latitude and longitude when we made the shape file, but we want it to be consistent with all of our other layers. So we're going to put it in 3413 because that's our favorite. And then down here, you could add fields. So if you wanted certain attributes to be associated with your lake, you could add a field for that. I usually end up doing that later. Do that. All right. So you make the file. There is nothing in it right now. All we've done is basically created a shell. So you have to actually edit it to add features. So if you highlight the layer by clicking on it in your layer manager there, and then you go and click on the pencil, now you have all of these editing tools for digitizing. And the one that you usually care about is just this add polygon or point or line feature. So if you click on that, you get this little guy here, and you can go through, and I'm going to do this very badly, but you could like more carefully outline the feature that you're interested in. And then you have to give it an ID. So if you had created other fields associated with this, it would ask you to fill that out at this time. But all we did was say we would have an ID for our feature. So you enter something for that. Yay, now you have successfully created first one. Don't forget to save it. That's very important. And then you may want to stop editing it so that you can't mess it up further by accidentally clicking on something. So we could go and look at the attribute table for this as well. Our attribute table is very boring because we didn't include any other fields in it. But if you want to go back later and you're like, oh, actually, there were things I wanted to record about this lake, then you can just edit in the attribute table directly. So the pencil is always the editing function. You click on that, you do that. And there is what's called the field calculator in here. So this is actually really convenient because not only can you add like text or something like that you know about the object or the ID, but you can actually have it calculate all of these things from the object here itself. So for example, we could say, okay, I want to add a field that is the area of this lake. So you don't have to measure the area of the lake. You can just say, all right, I want a field called area. It should be a decimal number. And then if you go into geometry here, there's this area function. You click on that, it automatically adds a field. And based on the geometry you do, it's going to insert that in square meters in this case. That's what the coordinate system is in. So you can also do this for like the perimeter, a bunch of other geometry features, which is kind of nice. Or if you wanted to say like add the lake name, you can just do the new field option. We'll say it's going to be the name. That should be a string. That's how many letters characters you can have in your string. And then you can edit here directly. Call this guy Cool Lake 2. This doesn't matter when you have one lake, but maybe you wanted to digitize like a set of these because you were trying to look at their dynamics over time, like as a whole. And so maybe you'd have like 5 or 10 lakes in here and you want to label them in some way. So you can then do these like extract by attribute things or other stuff like that later on. There we go. And then you save it, stop editing. So now we've got our lake. All right, so this one's for Nicole now. Nicole was interested in how we look at radar data. And so the first sad thing that I'm going to tell you is that QGIS will not help you with actually looking at like the radar images for ice penetrating radar because it doesn't really handle 3D things very successfully. So if you tried to pull them in, it probably just wouldn't even do anything or choke. But what we can do in here that's pretty convenient is pull in vector files of all of the radar flight lines and figure out like which radar segments would we want to look at if we just wanted to look at one over this lake in a certain year. And then you can go back to the files to pull those down and like look at MapLab or something. So for this case, I'm going to now add all of the vector layers from QGIS that show where the flights went in various years. Yeah, so every one of them, like in some ways, could be a tutorial in and of itself, which is super annoying. But let's see, for glaciology stuff, I would say a nice clearinghouse is the National Snow and Ice Data Center. So they're kind of the main repository for a lot of things. And you can go there and be like, okay, I want velocities. Like, what do you have? And ask for that. For the radar stuff, so that is hosted in part through NSIDC. It's also hosted through the University of Kansas webpage, which I will show you in the process of doing this. So in this case, like I went to their webpage and downloaded in bulk all of their KML files. Just to spare you all the process of me doing that, we're going to pull them from my hard drive. So, yeah. All right, so if you have KMLs, then they're just going to like prompt you for each of them for like which layer in the KML you want to add. It's slightly annoying. You just click yes for all of it, basically. If it had multiple layers, then you could choose, but these don't. So, all right, so now we have all of our radar lines pulled in, and very conveniently, there's a few that go across this lake. I wonder why I chose it for this tutorial. So we can go then and say maybe we want to figure out like which lines cross the lake. So one option for that is you can do the super zoom in and use this identification tool. Like you can just click on these and see, you know, okay, these are like the ones that cross over it. You can also do this thing called extract by location or select by location. And so you get something like this. And so we could say, okay, I want to get all of the features from, say, the accumulation radar flight lines in 2011 that intersect with my cool lake. Hit run there. Yep, and so let me turn off the others. You can see now. Yeah, so we've selected this one here. And so one of the things if you're trying to figure out like what you selected, if you go into the attribute table, this will take a minute. Whatever's highlighted in the attribute table is what's selected on the screen in the map, if you're trying to like check the features. So anyway, 2011 041601 crosses over our flight line. So creases is a little bit annoying. You also then have to figure out not just what flight line it is, because that goes all over the place, as you can see by the selection, but what, like, in this case, 19-kilometer long segment is like the picture that you want to look at. And so that's a separate set of KML files, one per flight line. So we could go, now that we know what date that is, and find that one and add it in to check. So it's going to freeze on me now, of course. So I loaded a lot of stuff. So I think I saved it here, spare us the time. Yeah, so we'll open that up. Okay, and so then if we click on this one, we can see here now what we were looking for is not just that date, but segment number 53. So if you want to go and actually get that data, that's where you have to go to the QGIS webpage. So it's this guy here, data.qgis.ku.edu. I will put this in the Google Doc I will send out afterwards with some resources. So this is where all the data's at. It is organized like as an FTP server. So this is why you may want to use QGIS for like subsetting and finding data files that you want, because all you're literally going to get is a list of directories on here. So in this case, we were looking at the accumulation radar data. So we will go, the L1B products are the ones that are actually radar images and not like gridded data derived from it. So we go here, and yeah, it's literally just like directories. So we were looking at 2011. If you come in here, so where I downloaded all of those KMLs are from the KML folders here. So if you click on those, you've got one for each flight line, and then you'll have one for like the season as a whole. So like I downloaded all of the season ones from the various directories here and have them saved off on my hard drive. And then, yeah, so what's useful for a first look is this images folder. So here they've just made like easily viewable JPEGs of all of the segments. So if you just want to see like what you're going to get without downloading data, images file was pretty useful. So we were looking at what is 41601, and then we were looking at segment 53. So scroll all the way to segment 53, and then you want to click on the echo. But we see our lake. Yay, it's there. So yeah, you got your surface, whole bunch of layers, and this thing right here where we've got the really bright reflector just below the surface, and we don't see anything underneath it. That's our big water body. So we've got a lake with a little bit of a refrozen lid as of spring of 2011. Yep, so it's a super glacial lake. Yep. And so if you wanted to do like actual analysis here, you would go to this wonderfully named CSAR QLOOK folder, which is the actual radar data, because obviously you should have known that. And then you go through the same like file structure. That's the wrong one, but anyway, when you go in there, it's going to be a bunch of MATLAB files. And so in that way, these are actually incredibly easy to work with if you use MATLAB or something else that can read .mat files, because it will just be a very normal like two-dimensional matrix of numbers that is the radar image, and then a little bit of metadata associated with it. So I do all of my radar viewing and processing in MATLAB, really in an outside program. All right.
Is DEM a better see the lakes? Several images.
Probably depends a bit on the season and whether you're looking for persistent lakes or not, right? So it'll be really obvious in satellite imagery if it's not frozen over because it's like a big blue spot. So if you're trying to just like look in the summer and see if there was a lake there in the summer, the satellite imagery is probably the right way to go. What's really nice about the DEMs is they'll capture lakes that are frozen over and may have been like persistently frozen over for years because they have this like very, you know, characteristic shape here in the DEM where it's just this like super flat spot in the bottom of a basin that's kind of like elliptical. So like when I'm scrolling for persistent lakes or for buried lakes, the DEM is really convenient for like a first order look at where those are.
Yeah. And are these lakes DEM? One in the summer.
Yeah. So it depends a little bit, right? Because this is a mosaic of pictures from many different times. So it's possible that it's a summer lake that drained or isn't persistent, and just the image that went into the mosaic happened to be taken during the summer. And so you got the surface of the lake. But a lot of them are ones that do like freeze over partway in the winter. And so like the reason that we still see them in the DEM is because almost every image has this flat spot because there's some remnant water in that location. So it depends a little bit on where you're looking. All right, so that was a little bit with the radar data. And then for Olivia, you were curious about how you can look at like changes in elevation, for example, over time. So we could look, for this example, we'll look at like how this radar lake the elevation changed over the lake over time from the DEMs, but you could do the same thing if you had a bunch of like melange DEMs. This process is pretty general. So if you're doing this with Arctic DEM, the first thing you would have to figure out is like what DEMs cover this lake. So you're going to need for this like the index of all of the strip maps that come in their various times. So you could download that. It's kind of a huge pain if you download it, but you can also basically stream the service from PGC that has that strip map like index in it. So this is this ArcGIS REST server option. So if you go to PGC, they will tell you how to get these. Let's see here. Yeah, so they have this like web services and application thing. And so basically, like we want the 2 meter strip index. So there's this URL that you can copy over. Then in QGIS, if you add a layer, you would instead add this the ArcGIS REST server layer, and you go in here. And you can give it a name, and you just put in that URL that it should point to. So I've done that already and added it here. And so we can just go to this strip index now, and we're gonna add that layer to our project. So you'll watch it slowly add all of these image titles over here. So this is not on my hard drive for once. This is something that I am streaming from a service online. So it's kind of nice for this big stuff where like maybe you don't want to save it, but you want to interact with it occasionally. You can just pull it in over one of these services. But as you will see, as this like slowly tiles in, right, there are like hundreds to maybe thousands of like tiles that overlap potentially with our lake. And you would probably really just want to pull out the ones that are relevant to you. So this is where extract by location really shines. So if we do this guy, what we can do is say, okay, we have this giant strip index of everything that covers all of Greenland. I only want the ones in this case that overlap with my pool lake. So there's various forms that you can do here of like the geometric. So an intersection would be that like 2 parts actually like cover each other. Touch would just be like the lines touch, that would also count. So overlap means that the lake has to be entirely contained within the boundary of the file. And you can go to the QGIS documentation to figure out what they mean by all of these. So it's not always intuitive. Yeah, so we'll run that. And so because we did extract by location, it pulled all of those out into a separate temporary file. And so now here in pink is the whole set of things that we actually care about that just cover our lake. So put them down there, you can see underneath the lake. Yep, so there's all the ones that cover a lake. For actually downloading the files, I find one of the easiest things to do at this point is then to like extract this list of tiles out into a CSV file that you can just like manipulate and look at a little bit more easily. So this is something else you can do pretty conveniently here. So if you right click, there's this export function and you can do save features as. So in this case, I want to save this out as a CSV. I always uncheck this button if you're just trying to look at it outside. Otherwise, it will try to add that back into your map file, and you'll have like 2 copies of the same thing for no good reason. You don't really need to change anything else in this. So if you do that, then we can go into tutorial. Okay, yeah, so now you just have a CSV file that's going to list like all of the metadata for each of those tiles. And in this case, like what we really care about is that for each of those tiles, there is here a URL that you can paste in your browser to download that particular tile. And if you're good at using something like wget, there are also ways to like just take all of those, put them in a text file, and like have your HPC server, for example, bulk download all of those from them. That's pretty convenient. And you can also use this to check like, you know, how good are these tiles? You might want to look, for example, at really valid area percentage is a good one to look at. If this like isn't over 95, then it's not worth downloading the DEM. It's just gonna be garbage. There were too many clouds or something when they created it. So like don't waste your time. Yeah. Yeah. Yeah, let me check my files. At some point, I had done this on the servers at Stanford. And so hopefully when I exported my whole directory there, I still have that shell script somewhere. So that, yeah. I will look for that. Okay, so for the purposes of this demo, I downloaded some files to look at because we don't want to sit here for 10 minutes while we download these like files to watch that happen. But you can do those things for yourself. Once you download them, you know, then you're just going to have a whole bunch of raster layers. So go back to these. So yep, so I downloaded a bunch of them here. So all of these SCTSM files are the ones that come from Arctic DEM. And so to your question earlier, Olivia, if you look, they have this like DEM 10-meter shade file that comes with all of them. So that's where they've automatically made a fill shade of the DEM for you. So if you just want to like pop it up and see if anything interesting is going on at like first look, you can add that file. The one that's actually got the elevation in it is called DEM. So I will add the 3 that I downloaded. So we have one from 2012, one from 2020, and one from 2021, just to look at things here. So we've got all of those. So if we're looking at how things are changing with time, right, there's a couple of things that you can do. One that I like to do with overlapping areas that's really fast for viewing is just to use the raster calculator to difference them. And then so you can have a map of like what's the elevation difference between those 2 time periods. So we do like raster calculator, we can, let's say, subtract, we'll do 2021 minus 2020. Y. And then you'll often find when stuff gets added, you're like, why does this look like garbage? And I see nothing. And it's usually because they set the like bounds for the color bar to something stupid. So if we go in here, yeah, it set like the no data value from the velocity is like the lower bound. So obviously we don't see anything. For elevation differences, maybe like negative 10 meters to 10 meters is pretty good. Put that on a diverging color ramp. Okay, cool. Yeah, so now you can basically just like scroll around in the sky and like look for interesting elevation changes that happen. So our lake, for example, between those years did absolutely nothing, but like this one down here had a pretty big elevation change. So if you expand these, it'll show your color bar and what it means, right? So if it's green, that's like plus 10 meters. So this one filled up. Maybe there's some that, you know, drained somewhere. Looks like this was mostly a filling year. Not too much in the way of drainage. Yeah, lots of stuff that had old basins that got filled. But you can just kind of scroll around the DEM and like find interesting things like pretty fast this way. You see a lot of structures. But I think what's also useful looking at these is that you will see how poorly calibrated sometimes the DEMs are to one another in terms of elevation. So like, for example, here you've got like this weird striping where there's like an elevation loss sort of up here on the top where it's brown, and then you've got like a green stripe where there was some elevation gain next to no elevation gain. Like when it gets that linear, it's probably not some magical new ice sheet process. It's probably like poor calibration of the tiles. And sometimes they'll be really off. You'll be like, why is there a 15-meter like bias between these two DEMs? Probably the ice sheet did not lose, you know, a blade 15 meters between those two times. It's probably just some sort of error in the calibration. So then with those, you kind of got to go through and you can use your raster calculator to like empirically offset them, or maybe you need to do a little bit of other analysis to like sort through it. So this is like one easy way to sort of scroll through and see what's going on. There's also a cool plugin that you can add. So this is kind of another great thing about QGIS because it's open source software. People can like write plugins to do things that the software doesn't do natively. So there's a nice one that you can download here in your manage and install plugins, this profiles tool that will do terrain profiles. So if we add a couple of DEMs to this, you've got to add layers. So we'll add the one from 2021 or 2020. You can make them colors. And then here, for example, and you can just draw a profile line through it, and you'll get the elevation profiles from the DEMs just like in real time there, which is pretty nice. And so there's an option, you can export this graph directly as an image. It also just takes a table of all of the data points, so you can export these like out to a CSV or something if you wanted to just like have that profile to work with somewhere else. And you can add, right, I've only done 2 DEMs here. You could add like 10 if you wanted, if you had a whole big time series of them, like look at it directly. And you can do some sort of direct measurement on this. Like it's got the little pointers that'll give you the exact X, Y, and Z coordinates, scroll around on it, that sort of thing. So I would say this is the sort of second most useful tool, like how an elevation should be in an area that you've got a big set of stuff. Yeah. Yeah, so that one with ISAT. So you think about like ISAT basically gives you this directly because you only get one measurement right directly underneath the satellite. So it's like automatically doing profiles. But this is very convenient if, for example, you want to combine ISAT profiles and Arctic DEM into like a continuous record, then you can be like, okay, just give me like the Arctic DEM profile like underneath the ISAT track so we can like put all of them together. This kind of profiling thing. So you can write your own profiler in like MATLAB to do this sort of thing, but it's kind of nice to like just have this click and scroll around and like do it visually option in QGIS. You don't want to mess with that, but for analysis, it may be easier to like write it yourself. And I have some code also that does that sort of thing if people ever need it. Cool. Let's see. Yes, that's profiling. All right. Well, we're 5 minutes over, and that's probably most of the cool things I was going to show. So we can stop there. If people had specific questions that came up or things that I haven't touched on that you really wanted to know how to do, take some questions.
So you reduce PhD from 5 years to 4 years.
After you spend like 1 month getting comfortable with the software, but yeah. It's very convenient. And you'll get kudos for your nice map figures.
Oh, this is extremely useful.
Yeah.
It's very useful for Josh as well.
Yeah.
So is there something can this be useful in plot stuff?
Yeah, so you can put anywhere in Earth on here, and actually technically other places, because there are coordinate systems for Mars or for Europa or for other celestial bodies. So if you had the direct graphically referenced data for Mars, those coordinate systems are included in QGIS. You could pull in Mars data and do the same thing in here. So yeah, yes, you can absolutely do Antarctica. You could do Antarctica in Greenland actually in the same map file with a little bit of messing around. I did that for a figure the other day. You just got to like toggle the coordinate systems when you're viewing stuff. Yeah. So I guess I should say for that, if you go, this is all like just, you know, doing sort of the analysis. If you go to projects, there's this layout manager. So if you make a new print layout, this is how you actually make maps. And so now you have like a page and you can, you know, go and like draw in a map and then it'll add whatever's on your screen like into that. Oh, there we go. Yeah. And so you can do like annotations and like add text and stuff on here and like change the views to make things look all pretty. It's a little slow, but.
And then this is where you would like save a figure as like a whatever JPEG, PNG, I don't know what you would do.
Yeah, so if you want to make like a figure for paper, you'd come in here and you know, you'll do like all of the adding of layers and everything, what you kind of want it to look like in the symbology, like in the map view. But then you come in here to be like, okay, I want the like map to be this shape and this size and this scale, and you can like add scale bars or add text annotations, like you know, do all the sizing and stuff. And then up here you have options to export as an image, so it's like a TIFF or a JPEG. You can export it as an SVG. You've got like stuff that's just strictly vector data, or you can export it as a PDF. So this is what I do for paper figures, is put it together in here and then export as one of those formats.
Gotcha. Cool.
Yeah.
Scaling for distance. As the
Yeah, so I'd say QGIS's functionality is not quite as nice as ARC's in that sense, but what you can do here is like when you do a new layout, so if you go to like, so if you do a layout, you have this option where you can save a layout as a template. And so if you say you make a map exactly like how you want it and always want it like this, you can save it as a template. And then the next time you create a new layout, you can load that template in and it will have all of your annotations and like the layout of the whole thing will look the same. And it'll just be adding whatever map data you have on the map like to the template at that time. And then you can tweak from there. So it is kind of doable in that way. I think ARC's is a little bit nicer in my opinion, but I also haven't used it in like 10 years, so hard to say.
One of the things that's so relevant to Josh is we need to distinguish the
Mhm. Yeah.
And so everything is a much better method to just get part of the DM data to do it first filter.
Yeah.
And there might be some like cool and stuff.
Yeah, I mean, I think like if you were using wintertime DEMs, right, summertime's like a little bit, because you only get one a year. If you have the summer DMs, it's a little hard to tell, like, did it just have water in it when you happen to get a pass or not? But if you have it, if it's not an empty basin in winter, like, you know, it's stuck around for a while. Yeah, so if you did like the wintertime DMs and just did this like differencing up front, I mean, you'd basically just be looking for like bullseyes in your imagery, which should be a kind of straightforward classification problem. You could probably even get it to classify maybe like the flat spots because they're so visually distinctive. Yeah. Right. Yeah, so I'll put up a Google Doc that has links to like how to download a QGIS and like the tutorials for people who've never used one before and those sorts of things. And I'll put some data links in that as well for like some of the data sources that I use in this tutorial. And if there's, so I'll send that around. And if there's other stuff that's not in there that you wanted me to like add as a resource, just ping me and we can add it to the doc.
Fantastic. So well designed.